Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Rifki Arif, NPM 22351075. Baik, di sini saya akan mengerjakan tugas pertemuan 14, menyimak suatu video pembelajaran. Langsung saja kita masuk ke dalam videonya.
How's it going? Welcome back to another video, and in today's video I'm going to be teaching you guys every single React hook. If you're familiar with my channel, I have a video already on this. It's actually my most successful video so far on my channel, and the reason why I wanted to remake this is because that video was made 3 years ago and I didn't even cover every single hook, and as of 2024 a lot of new hooks were introduced. Some hooks were removed and became completely deprecated, so I wanted to make a new video on this because it seemed like a lot of you guys really enjoyed my last one. My purpose of this video is very similar to my last one, where I don't intend you to watch the entire video at once, unless you actually want to learn all the hooks at once, but rather use this video as more of a cheat sheet. If you ever want to refine your skills or learn one specific hook that you might need for a specific use case, check the video part for that hook in this video. I obviously put timestamps on this video so you can just move around and choose the specific hook that you want to learn. And also, I'm going to not only put all of the code for this video in the description, but also I'm going to write a step-by-step version of this tutorial where you guys can just go if you want to, if you prefer text-based form. It's going to be on my website, so go to the description. It's pedrotech.co if you're interested in that as well. But yeah, that's basically it. Before we get into the video, if you could leave a like and turn on the notification bell, I would massively appreciate it, because as many of you guys might know, I'm returning back and posting videos. Never enjoy posting videos as much as I am right now, so I would really appreciate the support that you guys can give me. So if you're interested in doing that, feel free to do so as well. So now that we're done with all of the intro, let's get into the tutorial. Okay everyone, so let's get started. Before I get into our first hook, which is going to obviously be the use state hook, the most simple hook that you can learn in React, I want to explain a little bit about how I'm going to structure this code base in case you want to just follow the examples by going to the code base in the description. How I structure this is I have this folder over here called hooks. Instead of it, we'll have the example I'm using in the video for each of the individual hooks, also accompanied by any files that I use for the examples. So if you're interested in just checking out the use ID example, you can click on it and go in there. But in our case, we're going to start with the use state hook, and the way this file is structured is obviously just empty in the beginning, but we'll be including them in our app component as we go through the video, just to show them on our right over here. So let's get started with the use state hook. So if you are a complete beginner in React, you definitely heard of this hook, but I feel like this tutorial might help you even if you have already used the use state hook multiple times, in the sense that I will explain to you guys right from the beginning what's the purpose of a state, why you don't directly just get the DOM elements and edit their HTML directly like you would with normal vanilla JavaScript. States are the fundamental building blocks of a React application. Now, the example I want to use for the state here is the most simple example that I believe is used for describing states, which is the idea of building a counter. So in this component over here, I'm going to put a div, which is going to wrap a p tag, so paragraph tag, which is going to display some number, which is going to be the count. Then we want to have a button over here, which is going to interact with that number by increasing its value. So we'll say increase counter. Now, we currently have no way to store that number for the count, and we have no functions to call when you click the button. Before we create a state, let's just do it how we would normally do with a normal variable, as if you were playing around with JavaScript. I'll create a constant over here. Actually, I'll create a normal variable that can be altered, and I'll say count is equal to 0, and then I'll pass this value over here by passing count. Perfect. You see, now we see the count being 0. On this button over here, I'll create a variable called increase count, and inside of here we're going to put some logic to increase the count and pass this increase count as the on click to this button. Perfect. Now, normally speaking, if I want to make this variable go up, right, this value go up by 1 each time, what I could technically do is do count plus or equals 1, but you'll see that this doesn't work. Now, it technically increases the value. If I were to console log over here the value of count, you'll see that in our console over here, it should technically, when I click the first time, show 1, then 2, then 3, then 4. So the variable count is indeed changing. But why aren't we seeing that change over here? Well, because if you were using vanilla JavaScript, what you would do now is you would directly grab whatever p tag is displaying this number and change its value to represent the variable. But we're not doing that. We're using React, where our DOM needs to be updated and re-rendered automatically depending how the state of our application is. So this is the idea of a state. A state, in its most simplest form, is just a variable that you can create and change its value. And when its value is changed, it will automatically trigger a re-render of your page to demonstrate the new value. So how do we create one? Well, the way you do it is like this. You say const and then set an open and closing square brackets. Then you set it equal to the useState hook. It should automatically import it from React. Then we open and close parentheses, and you'll see that most hooks will look a similar way. Now, what do you put over here? Well, you put the initial value of what what you want your state to be. So in this case, count starts at 0, so we can put 0 over here. But this, you could also pass an empty string if your state represents a string, or even an object if that's the case as well. So we'll keep it at 0. And what do we put inside of here? Well, with the way that the useState hook is defined, and you can look at it if you want to, this should return back inside of here two things. The first is the value of your state, which is being called, you can call it whatever you want, let's call it count. And then it is a function that you can use to alter the state. So we're going to call this set count. Usually it has this notation with set in front and then usually the name of the state. But why do we need a function to change it? Because although this count variable is actually working similar to how it was before when we were using let, you'll see that altering the value of it by just increasing it like this doesn't work. Because what you have to do is use this setCount function and mutate the value inside of it. So we'll replace this over here and we'll open and close parentheses to call this setCount function. Now, what do I mean by mutating this value? Well, this function inside of here, it allows you to have a callback function inside of it. So a function that gives you access to the previous value of the state. So if count is 0 initially, the first time we call this prev value over here will be equal to 0. Now, if we increase it by 1, the next time prev will be equal to 1. So what we return from this function is just the new value of our state with this alteration. So when we call increase count, all we want to do is get the previous value and increase it by 1. If we wanted to decrease it, we could subtract or multiply or do whatever we want with this. But in our case, we want to just add it. And by doing this, we'll ensure that we're altering our state in the correct way and thus making React actually trigger a re-render because it is using the value of that state inside of this component. So you see now, if I keep clicking on this, it will keep increasing. Now, one cool thing that helps you understand more about the React lifecycle is looking at our old console log, this thing over here, right? If we go over here, we see that initially it's supposed to be 0, and we're not console logging initially. We only console log when we click increase count. So we are setting the count to be equal to 1 over here as the first touch of the button, and then we're console logging. So you should assume that when I click on this button, we should see 1 because it increases by 1 and then it shows 1. But you'll see that it's always lagged behind. It seems like it will always be 1 behind, even though it's after the set count. And the reason for that is because we're console logging before the page decides to re-render to show the new state value. And thus, the state actually only changes value after it's done running this increase count function. So keep that in mind. If you were to do set count over here twice, you'll see what will happen over here. It increases by 2 each time, but it also lags behind on both of them. See? So this is the most basic explanation of the useState hook. It will be the hook that we use for most of our other examples because it's basically the most simplest way of managing the state of your application in React. Now, there's other examples that you can play around with, but I think that this should be enough to get you going to the next ones. Okay, everyone. Now let's go into the useEffect hook, which is the second most basic hook in React, in my opinion. So I changed a bit the app.jsx that we had before. Instead of showing the state example, I'm showing the effect one. So if you're playing around with the code base, I would ensure that you do the same. So what is the useEffect hook? Well, the useEffect is one of the most powerful hooks in React, even though it gets a lot of backlash, especially nowadays. And as a beginner, you will mostly use it for doing stuff like fetching data from an API immediately when your page renders. So what the useEffect hook does is it lets you run code after the component renders, depending on a set of circumstances. So if I had a state, for example, and I wanted to run a function every time that state changes value, I could use a useEffect for that. If I wanted to run a function every time someone goes into my website for the first time or renders this page for the first time, I could use a useEffect for that. Now, how is that going to look like? Well, the example I want to give to you guys is the idea of fetching data from an API immediately when you go inside of the website. Now, I'm going to be using a public API that you guys can access. It is the JSON placeholder API. It just returns fake data for users. In this case, we're accessing data for like some posts. So like as if you're in Facebook making some posts. But the idea is that we want to go into our website over here. And when I first render the page, I want to run a function that will fetch this data and display it in my screen. Now, keep in mind, doing this inside of a use effect is one of the methods you're going to be using a use effect for the most as a beginner. But as you grow older in your React journey, you'll see that there's more effective ways of doing this kind of fetching data by using stuff like a React query, which is one of the best methods that you will probably learn later on. But let's get into actually building the use effect to do that. Well, the first thing we need to do is have a way to display that data. So I'm actually just going to display the data of the posts by creating an h1 tag over here, saying posts. And below it, I want to have an unordered list, which we're going to loop through the data that we get back from this API request and display the list items for each individual post, right? So to do that, I want to create the use effect hook. Perfect. You saw it also auto-imported over here. Now, the notation for the use effect hook is very simple. You call the hook, always obviously inside of your component, never inside of an if statement, just like all the other hooks. And inside of here, you put a callback function that will execute whenever your use effect is supposed to. So whatever action information you put over here, like console log page rendered, you'll see that it will actually console log over here. It runs twice because of some of the inner workings of React, where it basically runs twice when you're in development, not actually in production, because of React's strict mode. But you can actually disable that. The whole idea is that it should render once. So what I want inside of this use effect is to be able to fetch some data. But there's one last thing that we have to do to make this use effect work. After this function definition over here, we have to add something else, which is a dependency list. Now, what is the dependency list? Well, like I said, you can make this use effect run every time the page renders, right? But the page may render because of multiple things. It might just render once if there's no states inside of a component like we have over here, and you should see that only displaying once, like I said, right? But if I wanted to run this use effect or this function every time another state changes its value, then I would add that state over here. We'll get to that later on in the video, but there are multiple reasons why you might want to put like data over here. You could want to console log every time a state changes its value, and you could put that state as part of the dependency list. But in the case where we only want to run this once when the page renders, we want to keep it empty like this. Now, what we want to do is we want to fetch data from the API, right? So I'm going to come over here and I'm going to say fetch, and I'm going to put the JSON placeholder API link over here. And I'm going to actually use promises in this tutorial. So I'm going to say then I'm going to say, I'm going to grab the response from this then, and I want to turn that into its JSON format. And then I'm going to put another then that will convert this into actual data. So I'll grab the JSON and I want to do something with that data. Right now, let's just console log that data so you guys can see. Actually, I need to do JSON, and perfect. Now you should see that we get the console log over here with all of the data from the API. But how do we display it in our component? Well, we need to use what we learned in the previous hook, which is the useState hook, and utilize a state for this, because we want to have a variable in which when its value is changed, which means whenever we're done fetching the data, we want to re-render the page to show its value. So I want to come over here and I want to create one state for the data that we get back from the API. So we'll say data and set data. And inside of this use state, we need to put an initial value. So this will return a list of posts. So the initial value for this will be an empty list. Perfect. Now, we need to change this to, instead of just console logging the JSON data, I want to set the data state to be equal to whatever list we get from the API. Perfect. Now, to display this list over here, we'll delete this list item and add it back again later, but we'll just loop through this data. And for each item in this data, we want to map its value to some sort of JSX. So we'll grab the value of the post, and in this case, we'll create a list item for each of the items. And inside of this list item, you see it already shows the 100 list items that we got, but we haven't actually displayed any data from them. But inside of here, we'll literally just display the title. So I'll say item.title. Now we know it's title because we can see how the JSON data is formatted. It has a title with the actual title of the post. And the actual data updates to show that information. So this is something that we're doing without having to click any buttons, without having to do any actions. It runs when the page renders for the first time. Now, what about that dependency list that we talked about? Well, the best way I think to explain to you guys about this dependency list is to create another use effect that all I wanted to do is just console log the name Pedro. Now, what will this do? Well, I want to console log the name Pedro every time another state changes. Let's create another state over here. Let's call it something in the lines of show Pedro and set show Pedro. This will be a Boolean, so it will start as false, but it doesn't really matter because all we want to do is whenever I click on a specific button, that will actually create over here in the top as the example for you guys. I want to make a toggle. I want to basically, whenever you click on this button, it will turn this state into the opposite of what it is, right? So if it's true, it will become false. If it's false, it will become true. Because I want to show you guys exactly what this use effect dependency list does. So to do that, we'll just set show Pedro, and we'll do that by setting the value of the set show Pedro equal to the opposite of what it was before. So if it's true, it will become false. If it's false, it will become true. Now, let's inspect element over here. We'll see the console, and we'll see that it did console log the word Pedro a couple times. In this case, it does twice. Now, why does it do twice? Well, it does on the first render of the page, it does twice on the first render, like we said, but I haven't put a dependency list over here, meaning that every time any state in this component changes its value, it will trigger this use effect. That's why it's important for you to put a dependency list, because if I want this to only render whenever this is the first render, then we put an empty one, and you see now it's only showing twice instead of 4 times. Because previously, it would show twice when this page renders the first time, and then twice again when the data state is updated on this data fetching functionality over here. So what I want to do now is I want to make it such that every time I click on this button, it will trigger this use effect. Now, how can I make this use effect depend on this show Pedro state? Well, the name is already there. I can just put directly this over here, and now every time I click on this, it will trigger that use effect, as you can see over here. Now, this is the basic idea of how a use effect works.
AI is changing the game for app development. Firebase is here to help. We offer a platform.
Now, there's another aspect of the use effect which I won't get into this video, which is the idea of subscribing to events, because I think it's a little bit more advanced. But if you are an advanced person who already have experience and wants to understand this, the most basic idea is that you can use effects to subscribe and clean up from events like connecting to GraphQL subscriptions or connecting to Socket.io, connecting to an event that will consistently happen, maybe even a timeout. And you can then use the use effect to clean up that event. But I won't get into that in this video. I do have a more in-depth tutorial on the use effect if you guys want to check that out. But I think this is all I wanted to cover for this hook. Now, let's talk about one of the most important hooks in React, especially when you're starting your journey and you want to learn how to build applications that can actually scale and manage your states, which is the use context hook. Now, to make this example, I actually already built the context example component that we have over here because I want to showcase you guys the use case of the use context hook by first showing you guys an example of what problem it fixes. So imagine we have this scenario over here where we have this parent component, which is called the context example, and inside of it, it calls 2 child components. So we have one component called child toggle and one component called child display. Now, both of those components do different things. There's a state called isToggle over here, which starts off as false, but depending on its value, it will show this text either off or on. And how we alter that value is by clicking a button that exists inside of the child toggle. And you see, it does update that. Now, you might have noticed that both components utilize this isToggle and setIsToggle state over here that exists on the parent component. So to actually access that information, for example, in the child toggle, I need to access the setIsToggle function, and on the child display, I need to access the isToggle value. I need to pass that information as part of the props to the child, right? And imagine later on, you might need this information, this state that exists on this parent, on child components inside of this 2 child components. So imagine I have another component over here that would need this isToggle state. So I would have to pass it as prop as well. Now, what this does is it opens your app for some organization issues. It introduces a topic that is known in React as prop jelly, which, for example, if I wanted this grandchild component to access this toggle, but I didn't need this is toggle as part of the child display component, I wouldn't technically need to have it being passed as props to then pass to this. So it's prop drilling because you're drilling this prop through this component without it actually needing. Only the grandchild needs it. But because of how it is set up right now, you would have to do that. But it also can cause a lot of unnecessary re-renders of components. Because remember, if I'm passing something as prop, that means that every time that value is changed, it would trigger a re-render of this component, meaning that even components that don't need to be re-rendered would be re-rendered just because they have that value as props. So how do you do this? How do you make it such that every single child of this context example component and even the childs of them have access to some sort of store that contains all the states from this component? Well, that's where the use context hook comes in and the idea of managing your states through the context API. Now, before we write that, I want to point out, as a beginner, I recommend learning the context API for state management. But as you learn more and more about React, there are countless others libraries and solutions that you can implement. The most well-known ones are Redux, Zustand, React Query. There's a bunch of them. I have videos on a bunch of them as well if you want to check them out. But I definitely think learning the context API first is definitely the recommended. So how would we make it such that we don't have to pass this information as props? Well, the first thing we want to do is create what is known as a context. So I'm going to come over here and I'm going to call it const, and I'll call it the global state context. So I can call it whatever I want, right? Usually you call it depending on the context. But in this case over here, I want to make it such that all the components below this will have access to the state. So I want to make the state be global. So I'm going to call this create context by using the create context function from React. Now, I won't pass anything over here. I can pass null if I want to, but this won't matter. What matters is that now I can use this context that I created and wrap it around this whole context example component that I have. I can pass in the global state context and press dot and make a provider out of it. Now, a provider is like you're telling React which components you want to provide this global context to. So everything that exists inside of here will have access to the composition of states that you want to put inside of this context. Now, how do you put the states inside of here? Well, you pass a value to this provider. In our case over here, we only have one thing that we want to pass, which is both the isToggle value and the setIsToggle function. Those are the only two things that we really need. So what I want to create here is an object that will pass these two informations. So I'll pass the isToggle and I'll pass the setIsToggle. But if you had multiple states that you want to have to be accessed globally, you can also include them inside of this object over here. Now, this means that I can just delete both of these props, because what happens is now, I'll also delete it from here, sorry, and from here as well. Because now, if I want to access both the setIsToggle and the isToggle on these two child components, all I have to use is the use context hook, and you will grab values from a context that you provide it with. So in the child toggle, I want to grab the setIsToggle function. So I'll say const set it equal to use context, and I'll pass the context that I want to put inside of here. So I want to grab states from this context. That means that I can indeed grab the setIsToggle directly from this use context. I'll do the exact same thing here with the child display.
I have 12 emails, 30 messages, and a proposal due by 10. How am I already underwater?
I'm in the same boat.
But instead of grabbing the setIsToggle, I'll grab the isToggle. And you'll see that the whole app still works, even though I'm not passing anything through props. Now, this is the beauty of using a state manager, because you're able to create states that you can then use in multiple layers of your components. The example we gave before is the same. If I wanted to access this isToggle on a grandchild component that I create and call inside of here, I could technically just call this use context on there as well. And usually, I'm making all of these components in one file. Usually, you obviously have components in their individual files. So I would have a file for this child toggle and one for this child display. Technically, usually, you would export this global state context and just import it into all of those files. And you would put this on the top layer of your components, because everything that is inside of it, everything that this wraps around, will have access to the values that I put over here. So this is the most basic example and explanation of the use context hook that I believe. Now, again, if you want to get more into how to manage states and scale your applications, I would recommend learning more in-depth solutions like the ones I said before. Zustand, React Query, Redux, there's a bunch of them. So yeah, that's basically it for the use context hook. Okay, everyone, we just finished learning the foundational hooks of React. Those three are the ones that I believe are the most beginner ones, the ones that you definitely need to understand. Now we get to a stage where we're learning a bit of the additional ones, where it's not the end of the world if you don't actually learn them. Especially when I'm talking about the use reducer hook. This is probably one of the most underutilized hooks that I've seen from React, and there's multiple reasons for it. It is technically a hook that should be used instead of the use state hook to manage more complex state logic, like when you have multiple related variables or actions. It does use the same pattern as something like Redux because both of them use the reducer pattern. That's where the name use reducer comes from. And some people live by saying that you need to use the use reducer hook if your app grows beyond a simple app. But as you might hear from a lot of people, it is not technically required. I believe just using states can also be a good thing as well. So the best way to explain this is by putting a situation here in the screen in which we are using a use state. So I brought back the example from the counter app that we made, and I made it a little bit more complex by adding the subtraction as well, which was broken. But you can see it's a very simple counter app where I can add and subtract values, and it will appear over here. Now I could technically add as well more things. I could add a multiply, right? I could add a multiply over here and then make the prev multiply, and you'll see that this would also work. Actually, I'll multiply times 2. I'll double. Sorry about that. Yeah, you can see it works as well. So we have those three actions. Now, this is all being done with the use state, right? You see the use state over here. How would I do something like this using the use reducer? Because remember what I just said, the use reducer is an alternative to the use state for more complex actions. That's why I added an extra action over here. Well, the most simplest way to do that is, first of all, we'll replace this use state with a use reducer. It will automatically import over here at the top, and we'll just place it over here. Now, the use reducer has the same format as a use state. It will return two things, but the two things that it returns is different from what we have over here, although it has the same logic behind it. Similar to how we grab the count over here, in the use reducer, we'll grab the state, and the state will represent the count when we create our reducer function. The set count over here, instead of let's call it set count, let's call it dispatch, because we want to follow the reducer pattern, and all of this are part of that pattern. Now, inside of our use reducer over here, we want to pass two things. We want to first pass a reducer function, which we will create in a second, and we also want to pass an initial value for our reducer. So similar to how we had it before the count equal to 0 over here, we want to pass an initial value for this reducer. A reducer will be in the format of an object. So we'll pass an object with a count inside of it and an initial value of 0. Now, we want to create what is known as the reducer function, this thing over here. And we'll create it over here. So we'll say const reducer, and we'll pass in a function which will contain two things, a state and an action. Now, a state is just a placeholder value for the current state of your reducer. So in our case, we only have one piece of state in this reducer, which is our count. So if we want to access the current value of the count inside of this function, we can do state.count at any time. Now, what is the action? Well, when you want to change this state in any part of it, you can dispatch actions, and those actions should be handled inside of this function. So for example, over here in our set count over here, instead of calling set count, we'll just dispatch an action and we'll give it a type. For example, in this case, it's the increment action because we're incrementing. So we're not actually handling the logic of increasing or decreasing or doing anything inside of this. We're going to do all of that inside of this reducer function. And if I want to subtract, I can do the exact same thing, but by calling a dispatch of type decrement. And I'll do the same thing for double over here. We'll call it double. Now, where will we handle this? Well, we'll handle it over here, and we'll probably use a switch to check all of the action types that exist. So it's actually action type. So we'll come over here, we'll pass in the switch statement, and we'll check for all the cases. When the reducer function is called, we'll check for the case of the increment action. And if that's the case, we want to return what the value of the state is going to be like when this action is dispatched. So remember, the reducer state looks like this. It's an object containing all of the states that you want to have inside of this reducer. In our case, we only have one, which is the count. So if I want to make this increment action increase this count by 1, what I can do is say count is equal to state.count, because we'll get the current value of the count, plus 1. And this should handle the increment case. So we'll do the same thing for the next two cases. I'll actually just copy this and paste it twice. And this should go back, yeah. And then we'll make this decrement and make this double. So on the decrement, we'll just change this to -1. And on the double, we'll just multiply this times 2. Perfect. You should see now that this should technically work. And we'll put the state, replace this count over here. If I want to access the count value, I need to say state.count. And we should see that this does work. It's the same thing as we had before, but instead of using a useState, we're using this new hook called a useReducer, which definitely seems like a lot more work. I know a lot of you guys might be thinking that, but again, this is an alternative to the useState if you're more familiar with something like Redux and the reducer pattern. And this specifically also acts pretty well if you have multiple values on the state. For example, if this reducer was for a user, and the user had a name, it had an email, an address, it had multiple pieces of data that might want to be manipulated, you can actually keep all of the logic for manipulating this user directly inside of this single function, and then to just dispatch those actions over here. It might simplify everything. But one single case that I want to put before we leave is you do want to handle the case in which you accidentally dispatch something that doesn't exist, right? If I were to put a name over here that doesn't exist, I think this will break. Yeah, you'll see it breaks. So we want to put a default case over here. And in this case, let's just console log no reducer type. No, not action type. Now, what happens is, even though the name is over here, we should see that console log happening. And you can obviously throw errors, you can do whatever you want to handle that case. It doesn't really matter. I just wanted to add it because you don't want to have a switch case without a default to. So this is the basic idea of the useReducer hook. Okay, now we're going to talk about the useRef hook. And the useRef hook is one of the coolest hooks in my opinion because they're almost like I almost never use it. And when I use it, it solves exactly the issue I'm trying to solve. And I love it for that. Now you can use refs technically a lot in React if you personally want to. But its main purpose and use case is that the useRef kind of acts like a little box that can store a value, and this value will stay the same even if the component it was created in re-renders. So it is often used, and you'll see it being used for two different things. The first one is accessing the DOM elements directly if you ever need to, and we'll get to an example of that. And the second one is keeping a mutable value. So you can technically use the useRef hook to store values of previous of states, but like store the previous values of states, even though it will change due to a re-render. So the ref won't trigger a re-render when it's changed. So we'll see both of those. It's one of the ones where it takes a while for you to get used to it, but it is great to be used, especially when you want to hold values inside of your React application, but you don't want to display those values in your UI. So if you ever have a variable that you want to keep information of, but you don't want its value to change, but you don't want to display in the UI, meaning you don't want its value change to affect the re-render of your component, you could use the useRef hook. So let's start with the first example, which is accessing DOM elements directly, because that one is one of the coolest ones. So the first thing is if you have an input, and we'll return here just an input with a text, like a type of text. So type text. We should see that input over here, right? Now, if I want to get the current value of this input without using the useState hook, because if you are familiar with states and inputs, you should know that you can indeed keep track of whatever is typed on an input by just changing a state to whatever the value of the input is. But if you want to use a useRef for this, you can do it like this. You can create a reference to this input, let's call it input ref, and then set it equal to the useRef hook. Now, this useRef hook will allow us to make a direct reference to an HTML element. In this case, it will be the input. So we can come over here and set this as the reference by passing in a ref property and then setting it equal to our input ref. Now, if I want, I can create here a button that, let's call it onClick. I'll create a function that all it does is just console logs the current value of the input whenever we call this function. To do that, I'll create over here a button right next to this input. So we'll create the button and we'll call it console log. Sorry about that, console log. And we'll pass in this onClick to this button. So onClick equals to onClick. Now, obviously right now, it doesn't matter what's typed over here, it will just console log value. But if I want to grab the current text written on the input, I can access all of the HTML properties of this element in the DOM by using the input ref dot current. And this dot current allows you to see all of that information from a ref. And the best part is that whenever you update a dot current of a ref, which by the way is literally what a ref is an object with a dot current inside of it, with a current property inside of it. Whenever you update this current, it won't cause a re-render, and we'll see that. But in this case, if I wanted to console log the value, I can just say input ref.
Absolutely. You don't need any freelancing experience. The best part is
F.current.value. And you'll see that if when I click console log now, it should actually put the information of this input. So it allows you to grab specific things from the DOM. Now, another thing that it helps you do, that is, people love to point this out, is focusing, right? You can call functions that are primitive to the HTML element. For example, if I want to focus on this input, whenever I click on this button, I can just say input ref, actually I'll have to delete the console log. I can just say input ref dot current dot focus. And this is a function that exists in JavaScript. When I click on this, it should focus on this input, as you can see, and I can start typing. So this is the most common example of a use ref. But if you remember, I just said that if I change a value inside of this input ref, it won't trigger a re-render. For example, if I wanted to change the input ref dot current dot value, right, which we know represents what is currently typed on this input, and I want to change it to the word Pedro, you should see that when I click console log, which right now shouldn't even say that, but when I click this, it will change this thing to actually say Pedro. But if I were to create a use effect over here, right? Remember the use effect? If I were to create a use effect that updates and it will trigger this function, we're not going to put a dependency list. It will trigger this function every time the page re-renders. And we console log the text page re-rendered. You should see that obviously it console logs initially, then I'll type this once and I'll change it to Pedro. Even though the UI changed in a way, it didn't trigger a re-render. If you were using a state for this, it would definitely trigger one. So this is the main two use cases of a ref. Another use case is keeping count of the previous state of a state. So the previous value of a state. So I'm going to show you guys what this means. Let's create a state here and use the example that we've been using throughout this whole tutorial. We'll create a count. So a counter state. We'll start at 0 and we'll call it count and set count. Now let's change this to have a p tag that will display that count. And we'll say just straight up count. And then we'll have this button, which, like before, we'll just call a set count function to increase. So we'll say prev is equal to prev plus 1. And we'll change the name. I'll close this, and we'll change the name of the button to increase or increment. Perfect. So we have this counter example. We've been dealing with this through this whole tutorial, right? Now, what if I want to constantly keep track of the previous value of the count? So whenever count is 11, I want to keep track of what the value of this state was before. Obviously, because of the nature of this specific example, meaning to get to 11, the previous value had to be 10, it's kind of redundant. But states that can have multiple variations of its values, this could be very useful. Now, if I wanted to do that, what I can do is, first of all, set up a use effect that will be called every time the count changes. And we can do that by passing the count to its dependency list. Then what I can do is create a previous count ref. So I'll say const previous count is equal to use ref, and we'll set it initial state to 0 because that's the initial count. Now I want to display that p tag over here as well, and we'll actually put a label to this. We'll say previous count, and we'll put a count to this one. Nice. Now we'll pass in to this value the previous count dot current. Now, you might think this is weird because previously the .current value had stuff to it. It wasn't a number or a string, but now it is a number because we set it to be. We didn't pass this as a reference to a DOM element. We're using it as an actual variable. Now, when I click increment, you'll see that the count goes up, but the previous count doesn't because we're not doing anything with it. What we want to do is make it such that whenever the count changes, we want to set the previous count equal, previous count.current equal to the current count. So you'll see that it will always be equal to the previous version of the count state. So it's a good way for you to remediate how your states are changing and understanding how your app is working without actually causing issues like re-rendering. The best analogy I've heard for the useref hook is that it's like a sticky note that you can attach to a DOM element or a variable, and you can read and write it, but it doesn't really affect the rest of your component's behavior unless you explicitly use it. So it's one of the most important hooks in React, in my opinion, one of the most underused hooks as well. But at the same time, you start understanding it the more you run into situations in which you need to use it. Okay, everyone. Now let's talk about the use imperative handle hook. It's probably the hook that you'll use the least by far out of all the hooks. If you watch my previous React hooks course, I also mentioned this. And I gave one use case for that, and I believe that's the only use case I ever ran into where I needed to do this, especially because the main pitfall of refs and the use imperative handle hook as a whole is that you shouldn't be overusing refs in your projects. So the use imperative handle hook is only used whenever you are using refs and in a specific use case to it. So it's the kind of thing where, to be honest, if you want to skip this part of the video, feel free to do so. I even want to go through it fast because I don't think it's actually explaining by typing everything will probably give a worse explanation. So I already built up an example over here of how the use imperative hook can work. And I also wrote some comments so that you guys who are just looking at the text can actually understand everything as well. So the use imperative handle hook works by basically allowing you to customize the ref you decide to expose to a parent component. And it's very useful when a parent component needs to interact with a child component and you want to control exactly what the parent component can access from that child component. So in the best and easiest way, I think, is it's basically a way for you to decide what the parent can see and do to a child's ref. And the way you can do this is, for example, when you have a parent component, and in our case, it's the imperative handle example that we are displaying here in the screen. And imagine in this example over here, in our parent, I want to have buttons that directly interact with a ref that exists in one of its childs. Now, in this example, and the actual data updates to show that information. So this is something that we're doing without having to click any buttons, without having to do any actions. It runs when the page renders for the first time. Now, what about the dependency list that we talked about? Well, the best way I think to explain to you guys about this dependency list is to create another use effect that all I wanted to do is just console log the name Pedro. Now, what will this do? Well, I want to console log the name Pedro every time another state changes. Let's create another state over here. Let's call it something in the lines of show Pedro and set show Pedro. This will be a Boolean, so it will start as false, but it doesn't really matter because all we want to do is whenever I click on a specific button, that will actually create over here in the top as the example for you guys. I want to make a toggle. I want to basically, whenever you click on this button, it will turn this state into the opposite of what it is, right? So if it's true, it will become false. If it's false, it will become true. Because I want to show you guys exactly what this use effect dependency list does. So to do that, we'll just set show Pedro, and we'll do that by setting the value of the set show Pedro equal to the opposite of what it was before. So if it's true, it will become false. If it's false, it will become true. Now, let's inspect element over here. We'll see the console, and we'll see that it did console log the word Pedro a couple times. In this case, it does twice. Now, why does it do twice? Well, it does on the first render of the page, it does twice on the first render, like we said, but I haven't put a dependency list over here, meaning that every time any state in this component changes its value, it will trigger this use effect. That's why it's important for you to put a dependency list, because if I want this to only render whenever this is the first render, then we put an empty one, and you see now it's only showing twice instead of 4 times. Because previously, it would show twice when this page renders the first time, and then twice again when the data state is updated on this data fetching functionality over here. So what I want to do now is I want to make it such that every time I click on this button, it will trigger this use effect. Now, how can I make this use effect depend on this show Pedro state? Well, the name is already there. I can just put directly this over here, and now every time I click on this, it will trigger that use effect, as you can see over here. Now, this is the basic idea of how a use effect works. Now, there's another aspect of the use effect which I won't get into this video, which is the idea of subscribing to events, because I think it's a little bit more advanced. But if you are an advanced person who already have experience and wants to understand this, the most basic idea is that you can use effects to subscribe and clean up from events like connecting to GraphQL subscriptions or connecting to Socket.io, connecting to an event that will consistently happen, maybe even a timeout. And you can then use the use effect to clean up that event. But I won't get into that in this video. I do have a more in-depth tutorial on the use effect if you guys want to check that out. But I think this is all I wanted to cover for this hook. Now, let's talk about one of the most important hooks in React, especially when you're starting your journey and you want to learn how to build applications that can actually scale and manage your states, which is the use context hook. Now, to make this example, I actually already built the context example component that we have over here because I want to showcase you guys the use case of the use context hook by first showing you guys an example of what problem it fixes. So imagine we have this scenario over here where we have this parent component, which is called the context example. And inside of it, it calls two child components. So we have one component called child toggle and one component called child display. Now, both of those components do different things. There's a state called isToggle over here, which starts off as false, but depending on its value, it will show this text either off or on. And how we alter that value is by clicking a button that exists inside of the child toggle. And you'll see it does update that. Now, you might have noticed that both components utilize this isToggle and setIsToggle state over here that exists on the parent component. So to actually access that information, for example, in the child toggle, I need to access the setIsToggle function, and on the child display, I need to access the isToggle value. I need to pass that information as part of the props to the child, right? And imagine later on, you might need this information, this state that exists on this parent, on child components inside of this two child components. So imagine I have another component over here that would need this isToggle state. So I would have to pass it as prop as well. Now, what this does is it opens your app for some organization issues. It introduces a topic that is known in React as prop jelly, which, for example, if I wanted this grandchild component to access the isToggle, but I didn't need this isToggle as part of the child display component, I wouldn't technically need to have it being passed as props to then pass to this. So it's prop drilling because you're drilling this prop through this component without it actually needing. Only the grandchild needs it. But because of how it is set up right now, you would have to do that. But it also can cause a lot of unnecessary re-renders of components. Because remember, if I'm passing something as prop, that means that every time that value is changed, it would trigger a re-render of this component. Meaning that even components that don't need to be re-rendered would be re-rendered just because they have that value as props. So how do you do this? How do you make it such that every single child of this context example component and even the childs of them have access to some sort of store that contains all the states from this component? Well, that's where the use context hook comes in and the idea of managing your states through the context API. Now, before we write that, I want to point out, as a beginner, I recommend learning the context API for state management. But as you learn more and more about React, there are countless others libraries and solutions that you can implement. The most well-known ones are Redux, Zustand, React Query. There's a bunch of them. I have videos on a bunch of them as well if you want to check them out. But I definitely think learning the context API first is definitely for the box width until this ran, and then it set the correct information. So this is all that the use layout effect does. It just runs before the use effect. It runs in that small gap between the DOM existing and having its changes and the UI being painted into the screen. Now, it is good, like I said, for doing stuff like getting sizes or positions for a DOM element. And it's good as well for synchronous DOM updates when you specifically need to update a DOM element and avoid flickering or incorrect measurements. So in this example, if we were using the use effect instead of the use layout effect, this would have to run twice because the page would have to render twice because the use effect would render first without this action, and then it would trigger the set box width because it would get the information, and then it would render again. It would cause a little flicker that we saw. We don't see it anymore because everything is very stable. But if I were to change this, maybe let's put it to 90 again. Yeah, we didn't see it, but imagine in a larger scale project, you should see it. And the use layout effect allows you to have access to that specific part of your component lifecycle. Now, you might be asking, why not always use the use layout effect? Won't there be thousands of situations in which you might want to be doing your changes before you paint to the screen? Well, the official React documentation recommends against it. It basically says that it blocks the browser from painting until it finishes, which can hurt the performance of your application if it's overused. So they specifically recommend that you use the use effect for all other tasks and only use the use layout effect when you need exactly the use case that I mentioned in this example. So if you're a beginner and you're looking to use the use effect for stuff like data fetching, logging, you really don't need synchronous execution, then if that's the case, just stick to the use effect. But if you want to deal with positioning and DOM element widths and sizes, use the use layout effect. Okay, everyone, I'm going to talk very briefly about the next hook that we have over here, the use insertion effect hook. The reason for it is because even the React documentation only recommends you to use this hook if you are an author of a CSS in JS library, meaning that if you are an author of a library that uses CSS styles and deals with all of that, then this would help you massively. But if you're a normal React user who don't do that, you'll probably be better off using other alternatives, like, for example, the previous hook that we talked about, the use layout effect, and the use effect hook. Now, why am I even including it? Well, because this is a full course. It's an updated course on my previous course, which I did around 3 or 4 years ago. And I want to include everything, including things that I don't think you guys would technically need to use. But if you guys are interested in going to this timestamp of the video and watching this, feel free to do so as well. So what is the insertion effect hook? So the use insertion effect hook is basically, like I said, specialized hook that runs synchronously during the rendering process, but differently from the use layout effect hook, it runs just before the mutations are made to the DOM. So it is designed for cases where you need to insert styles, meaning CSS styles or style tags, like we have in this component over here, into the DOM during rendering to ensure that they're actually applied immediately. So you can see that you'll probably never run into a situation where you need to do something like this, and you will be much better off using the other alternatives. But as specified by the React creators, this is primarily intended for CSS and JS libraries, like style components, one that I personally used a lot in the past. And the reason why they benefit from using this is because they're able to inject critical styles into the DOM before the browser even attempts to paint the UI. So this will avoid situations where a component briefly renders, but without any of the styles, and then it flickers to the component with the styles. So it's similar to the use layout effect in the sense that it will prevent those flickers, but this is specifically talking about styles. So I'm not gonna go too much in detail with this example over here, but we see that we have here a div, and in this example, we're using the use insertion effect hook to style this div, which basically just means setting a color for the text and like setting a background color to blue. But we're doing all of this at a different stage from where we would if we were to just come over here and add a style tag, because we're doing this before the DOM mutations happen. And like I said, this can be very beneficial in some cases. Obviously, we aren't seeing the benefits over here, but you're able to see a specific use case of it. It's very similar to a use effect hook. And obviously, in this case over here, we're creating a style document element and appending it to a specific part of our document. And this use insertion effect will run during the rendering phase. Then it will insert the style tag with the dynamic styles that we want into the head of our document, and the browser will apply all the styles right before painting, which, like I said, will ensure this not to flicker. And when the component unmounts, which is the return, similar to a use effect cleanup method, it will clean up all the inserted styles. So this is the use case. I'm not going to spend too much time in this. Also, this is a very new hook, so you need to make sure that you even have the version of React to support it. And there might be some browsers that don't support it because obviously it's a new version, so it's something that needs to be more and more adapted with time. But like I said, it has a very limited use case, so if you're a beginner, I wouldn't even attempt to understand it. But that's basically the best explanation I can give for this. Let's get into the next hook. Okay, so now let's go into the next hook, and we kind of left a little some of the more rare use case scenario type hooks that we just talked about, and let's get into one that is from the newer version of React, but I personally have been using it a lot ever since it got released because I think it's very cool, which is the use ID hook. Now this hook in React basically generates a unique and stable ID that we are able to use for elements in our component. So this is great for a variety of reasons. If you're familiar with accessibility, you want to have your app be very accessible to everyone. So you use something like you create an ID for an input and you link a label to that input. And this is very common by doing something like this, where you set an ID to an input and then you set an HTML4 to a label that links to this input. In this case over here, we have a name label and the specific input that would take the value for the name, right? Now, what does the use ID hook help us with? Well, by generating unique IDs, we ensure that we have unique IDs across the server and client rendering, which is critical for server-side rendering apps like Next.js and other libraries that does some server-side rendering. So as you get familiar with server-side rendering, you'll notice that this is extremely important, and this hook that they provided with works seamlessly. It provides this ability to ensure consistency and stability across the renders of your components, and it will prevent any type of ID collision between your labels and your inputs. Now, we have here, as an example, how we used to do this is we would just set an ID and an HTML4. Obviously, they're the same since we're linking both this label to this input. And if you went over here, you would see in the element that the specific element for this input and this label has an ID of input1, which I specifically set over here. Now, with the useID hook, what I can do is I can come over here. I can just generate an ID variable called the useID hook, and this should give me a unique ID that I can use to set my labels and inputs. So I'll put over here ID for this one, and I'll put ID for this one. And we should see that now when we refresh this, the ID is a unique one. So it says R1 over here. Now, if I were to have another input and another label, for example, I could have another one over here, and I can just generate another ID and call it something like ID2, and then put the same variables over here. You should see that they do have different values. And also they are unique, right? So they generate different values at every time you render this. But since you're using the same variable, you don't have to handle all of the uniqueness. It will do it all for you. Now, there are a couple things that I would say are best practices. For example, I would say use the useID mostly for labels and inputs, but also for just dynamic elements, like whenever you have a section that might...
Hi, my name is Bruno Brizzi. I'm a creative coder.
Collapse into other elements, or specifically if you want to keep track of different tabs in your website, you might want to use the useID as well. And also, one mistake I see a lot of people doing is when you're inside of a map, where like you're mapping through a list and you're displaying items, and you want to put a key, right? The key property. A lot of people want to just put the ID, but no, use the index or the ID of the key of the mapping function to keep track of those elements. Don't use this useID. It goes against the purpose of this hook. And if you are a beginner watching this, just see it like this. The useID is like a handy name tag maker. That's the best analogy I've seen so far. It just makes it such that each component gets a unique tag, which is the ID, and it makes it really easy to identify and link the elements without worrying about duplicates or conflicts. Now, let's talk a little bit about the use transition hook, which is one of the coolest new hooks that React has to offer. Now, the use transition hook is mainly used in React when you're dealing with a situation in which you need to handle non-urgent updates. That means that if you want to prioritize some sort of update to your component, like for example, when you interact with like when the user interacts with an input or a button, and you want to defer less critical updates so that your app is more smooth, you can use the use transition hook. Now, this can help your user experience a lot because it ensures that user interactions, which are very like important updates, are done quickly or given a response quickly. And some other updates that might require a little bit longer, like for example, filtering data, which is the example we're going to be doing in this component over here, will be put in the background until it's done. Now, what most people use it for is what we're going to be showing here, which is showing a loading spinner while you're doing some sort of hard calculation. So you notice here, what this component is basically we have here an input, which searches and filters through a list that we generate automatically over here. This list has 10,000 items, and all of the items in the list are basically just the word item and then the number of the item. So what we do here is, as we type on the list, we're able to filter for the specific items that we're writing, right? So for example, if I put one over here, there's only one item with this because there's 10,000 items. But it will automatically filter everything, but it does feel a little bit like not smooth because as I'm typing this and as this list grows, it will indeed need more time to calculate stuff. For example, if I were to put another 0 over here and I were to continue typing this, it's still smooth, but if I were to add more and more, right, this would get pretty tough. It can even break. As you can see, it just broke my app. Let me go back. But yeah, calculations do get expensive, especially when you to your memory. So the thing is, whenever it's loading a calculation, you want to show the user some sort of immediate update to notify them that something is happening, like for example, showing a loading spinner whilst you do the calculations. So you're basically prioritizing an update to your UI, which is the loading spinner, while putting the update of showing the new filtered items to the background. Now, how you do that is with the use transition hook. So what do we do in this case? Well, we'll come over here at the top and we'll call the use transition hook like this. And it will give us back two things. One is the transition pending? And the other one is, well, this is a function to start the transition. Now the is pending is what we want for our UI, because I'll come over here and I'll just say, okay, is the transition pending? Because if it is, I want to show a little p tag that says loading. So it's a little loading screen for us. Now, how will it know what transition is in progress? Well, we'll wrap around the expensive filtering over here and use the start transition, and then just pass all of this information as a callback function. So we'll do this, we'll save it, and now the use transition hook will know what is the expensive calculation, and when it's done, it will set the is pending to false. So we'll see, as I'm typing, you'll start seeing the loading screen. So I'll say item, and you saw that for a second, it prioritized showing the loading like text before showing the actual filtered items. Because if I wasn't doing this and I wasn't using the use transition hook, it would just show me whenever it was ready. But in this case, it will show a loading screen, and it will continuously show whenever it requires time to load stuff, which at the end it doesn't require that much. But in the first time you type item, it does require, because it's looking through everything, right? So this is the basic example of why you might want to use the use transition hook. I use it a good amount. It keeps interactions with the users pretty smooth. It avoids UI freezing during like expensive updates, and it overall just improves the user experience because it shows loading states when usually previously I couldn't show loading states, or at least I didn't used to, because I obviously use loading states when I'm fetching data from an API. But with something like this where I'm filtering data and doing everything on my code, I don't really have alternatives other than this, or I didn't used to. So I do think it's great, especially for situations like filtering, which is the most common use case I've seen. Now, if you're a beginner and you're watching this, I would say that the easiest analogy to understand the use transition hook is that it allows you to
Tiga tanda anak Anda memiliki kemampuan pemrograman. Pertama, anak terus-menerus main games.
put less attention to the important work, which is in this case filtering the items because it takes longer, and put immediate attention to an easier thing to just show to the user, so that users get immediately happy with what they're seeing. They're seeing something happening, they're seeing the loading screen, while the complex and hard thing is being done in the background. So I personally think it's especially useful for improving performance and improving user experience in large or complex apps. Now let's go over the use deferred value hook. This hook is extremely similar to the previous hook we just explained, the use transition hook, but it has some minor differences that completely change the use case of it. We're going to be using the same code example as before because I feel like it will help explain the difference between them, but in its core, the use deferred value hook, it helps you delay updating a value until the app has time to process it. It is specifically useful for smoothing performance when the current value is updated too frequently, like when you're typing on an input to try to search and filter for a list, and you're typing too fast, which makes the state update a lot, meaning that it might cause issues with the performance of how your states are, or how your components are updating. So the main characteristics of this hook is that it will allow React to prioritize rendering the urgent updates, like the user typing, but it would also delay less critical updates to avoid blocking the main thread of your application. And the best part is that it doesn't require any manual logic, like using the use transition hook, where you had to specify where in your app you wanted to start the transition. So in this case, it is very similar to something like a debounce that you might be used to if you're, I don't know, writing search queries that searches or fetches data from an API based on what someone is typing on an input, but it has some differences because in this case, we're not delaying the execution of the filtering or the API request. What we're doing is just deferring the value update to reduce the cost of rendering that information. So how exactly would we implement it here to make something similar to what we did with the use transition hook? Well, what we would do is we would say use deferred value over here in the top. And then we obviously have right here an input and we have a query variable, right? That it represents what we're searching here. So we'll put 2, 3, this goes to the query state. And then we have this items list is the same one as before. And then we filter the list. Now, what I want to do is when we do this calculation here, right? The items calculation, the filtering, I want to, instead of using this query variable here to basically check to see if this item is included in this 10,000 sized list, I want to create a deferred version of this query. I'll say deferred query, and I'll set it equal to the use deferred value hook and pass in the query. I'll defer this value exactly for the reason of having smoother performance, because now if I use this defer query over here, it should already be working. Now we obviously don't see it directly. We can also get the loading spinner like we had before, because now we have two pieces of information. we have the query and we have the deferred query. And we know that the loading screen will only be the case, it's only loading the data if the query is not equal to that deferred version of the query, the one that is waiting to be done with the calculation until it's set. So we can just ask if query is not equal to deferred query, then we can show a loading screen. So we'll say p tag and then loading. And again, this is crucial for when you're dealing with complex operations that would benefit from reducing the cost of rendering. And it's mostly with like something like typing fast, like I'm trying to do right here, but it will actually not make you run into issues where it's taking a lot of time to filter through that list. Now, you might still be wondering, how is this different from the use transition hook? Well, it differs in what it does, when to use, and how it works. Because what it does is it defers a value from propagating immediately, when the use transition hook, on the other hand, defers the state to update or render some sort of task. And then on the part of when to use, you would probably use the use defer hook whenever you're working with frequently changing values, like this input. And it just happens that the example I used for the use transition also involved typing on inputs, but the use transition is mostly used when you specifically need to render heavy UI or updating a specific state. And finally, the way you use it is different, because this will automatically delay the value. When the use transition hook, you need to specifically wrap whatever you're trying to calculate around with the start transition function. So this is one of the most useful ones, I think, from the new hooks that we have so far, together with the use transition hook. I think there are things that a lot of people probably didn't realize would really benefit them and their projects, and React is really handing down the whole part of improving performance, because that's definitely something that will help React in the long run. Now, let's talk about the use sync external store hook that was recently introduced in React 18. Now, to explain this hook, I made this example component over here, which is a very simple component that just fetches data from the Pokemon API and displays the list of Pokemons. Now, we're going to change this hook to be using the use sync external store, but in order to do that, I want to just explain a little bit about what this hook is. Well, the use sync external store hook is designed to let components be able to subscribe to external stores, like for example, global state libraries or custom state managers, in a way that's very safe for concurrent rendering. This was introduced in React 18 to solve issues with concurrent rendering when you're dealing with situations like this. It ensures that your component stays in sync with whatever external state you need, and it avoids issues like tearing, which is basically when your rendering is inconsistent during updates. Now, the use sync external store hook looks like this. You'll create a variable called state, and we're not currently implementing on this example. I just want to show how the hook actually looks like. But we'll create a variable called state and set it equal to the use sync external store. And then this hook, you need to pass technically two things, but you can also optionally add a third thing. The three things you need to add is, first, a subscribe function. So we'll have to create that, which will register a listener for any external state changes. Then you'll also pass in a get snapshot function.
Buat website praktis dengan AI Website Builder Hostinger. Tulis konsep website, lalu tunggu AI buat website. AI bisa atur warna, gambar, font, dan teks sesuai konsep yang Anda mau. Edit tampilan website sesuai.
Which will also create, which its main purpose is to return the current state of a store. And then there's also the optional thing that you can pass here, which is a function called get server snapshot, which this is specifically meant for when you want to provide a snapshot for server-side rendering. So in this example that we have over here, what we want to do is create a custom store that will fetch the Pokemon data from the API. It will update the state and notify all subscribers of this store when the data is ready. This means that you can create a store for some sort of API data and have a lot of components subscribe to the store so that they can be synchronized with how the data is updating. So how would we do it in this case? Well, I'll create another file over here inside of our use sync external store folder, and I'll call it the Pokemon store.js. Inside of here, I'm going to create the things that I need for this, like the subscribe and the get snapshot. Since I'm not using server-side rendering for this, I'll remove that. But we'll create those and we'll import it on this file. So the first thing we want to have a store for something like this logic of fetching Pokemons is creating a state variable. So we'll create a state, and it will be an object, and we'll have one piece of information, one property called Pokemons, and it will be an array. And we'll call this the initial state. Then we'll have some listeners, which will also be a list because it will be the list of our subscribers. Then we're going to have a function over here that is going to fetch the data and update the state. So inside of here, we're going to create and export a fetch Pokemon's function, which will be async. And we already have that logic, so I'll just paste it over here. I'll grab this over here, paste it. Now, one thing you might have noticed, oh, actually, I'll delete this. One thing you might have noticed is that we don't have a set Pokemon's state like we have over here. So instead of saying set Pokemon's, what we can do after we get the data is we can set the state variable that we have at the top equal to Pokemon's, and then set the data dot results inside of here, because data dot results is how we get the information from the Pokemon API. And then we can use that listeners array to loop through each of the listeners, so every single component that is subscribed to this, and we'll call a function called listener, like this. And then we'll go through the listeners array, which contains all of the components that are subscribed to this store, and we'll grab each listener. React will automatically set this callback function to have this listener function, which we can then call. So React does this for us. And then this will notify all of the subscribers.
You're looking to make your app the best it can be. It sounds simple, but the reality is anything but.
And then down here, we're going to just create a variable called the get state. It's a getter for this state, the state of our store. And we'll also have to create the subscribe function. So I'll say subscribe is equal to listener, because this will be passed by the useSync external store hook as well. And inside of here, we'll grab the listeners array. So if I want to subscribe a component to this, I'll just grab that array and push the listener that we're connecting through the hook. And then when we finish this, we also want to clean this up and return back function where I said listeners is equal to listeners.filter, and we'll just filter out if the listener is already there. So I'll say L is not equal to listener. This is just some logic to keep it. I know it's a bit confusing, I recognize that, but this is a very common pattern that you might see when creating a store like this. And it makes it very easy because now we can remove all of this logic from here directly. And in this sync external store, we can grab the subscribe function from that file. We can also get the get state function, or the function, the getter that we created from this file as well. Now we'll delete the state. We don't even need a state anymore because this will handle everything for us. Inside of this, we'll get back a state object, which we know has the Pokemons inside of it. And we do need to fetch the Pokemons. So we have created this fetch Pokemons function. So I'll just call it, actually I'll call it over here, the fetch Pokemons function. And we'll just have a normal use effect that we'll call it on the first render. So we'll just call it over here, and I'll put the dependency list as empty. And you'll see that this does work and it handles everything for us. Now, the great thing about this is that any other component that needs to access this data now can just use the useSync external store hook and handle all of this automatically without having to write all of this logic every single time. Now, this is great. I haven't personally used it that much since it got released, but it's great because it keeps state management separate from component logic. It also ensures that your component is always in sync with the store, even if you're in the situation of concurrent rendering mode. And I think it's a pretty simple structure when you get used to it. Now, one thing you might be questioning yourself is, why didn't we just do all this logic inside of a context and then use the useContext hook to grab that data? Well, there's a couple of things that differ between doing that and using the useSync external store. I think it mainly differs on purpose, performance, and reactivity. So talking about the purpose, the useSync external store, like I said, the purpose of it is just syncing React components with some sort of external store. Whilst the useContext hook and creating a context, its main purpose is something else. It's sharing state and data across a component tree. Now, you can indeed do something similar using either of those. But where it becomes very different is the performance, because with the useSync external store, it's specifically optimized for React concurrent rendering, and it will avoid unnecessary re-renders. Whilst the useContext, every single component that is consuming the context will re-render when the context value will change, which in some cases might cause performance issues. Now, the last thing is reactivity, because the useSync external store components only update when the store changes, whilst in the useContext hook, the context triggers updates for all of its consumers, even if some of them don't need change, which goes hand to to hand with what I just said about performance. And I feel like in situations where you're just sharing static or infrequently changing data across some components, maybe some global states like the theme of your website, or if the user is authenticated or not, maybe use a global context. But in this case over here, if you're syncing with global state libraries like Redux, or you're using external state sources, something like the Sync External store might be good for you. Thank you so much everyone for watching this video. This was a lot of work, and I would really appreciate if you guys could leave a like and turn the notification bell on, because that would tell YouTube that you want to watch more videos like mine. And if you enjoyed this one, you'll probably enjoy the next ones I'm going to post as well. Again, don't forget to check out my links that are going to be in the description, especially my website, which is going to contain a text-based version of this tutorial so that you can later on reference if you ever need to. Again, thank you so much for watching this video, and I see you guys next time.
Baik, setelah selesai video menyimak, sekian, terima kasih.
Helen